to mute everybody there. Some people have microphones turned on. You can definitely turn on your microphone to talk if you have questions. Off initially. Hope everybody had a good weekend. So what's going on? We have a test coming up, and you have an assignment out to work on. I'm sure people have questions about that. So if there's questions people have, you can post them up as usual into the Piazza boards. There's a live Q&A board started, so people can vote on questions. If not, I'll go through some of the ones that are up there already. There's some that had not had answers that are relevant for the test. And you can post messages into the room chat here as well. Great. Okay, in which, yeah, we're on this screen. Right, I guess I could do that. Just have a learn up there for people to look at. So yeah, we got the test one description. It'll go live hopefully tonight or early in the morning on Mobius. It's mostly multiple choice, true-false selections, or you enter in a number for some calculation, as well as a derivation example of the similar kind to this MLE map thing that we've posted a couple examples of. And if you didn't see it, there was an additional one posted from Elad on the weekend with a another example for that one. Yeah, and then there's also the assignment, which is out. Hopefully this one will be fun. Do please take a look and see, because as always, there can be, you know, issues with the data set or the way things are put together. And that's partly by design in a way that we can only create it so well. So when you have a given data set, there may be issue with it or things you have to clean up or interpret or convert a column. Data is usually not completely clean. Well, this one we don't expect to have missing data and stuff, so we've done our best to put it together and make it make sense. So hopefully that works, and you've got a kind of classification problem there. I haven't been able to get, I had an idea of how Kaggle, so we're going to have a Kaggle part where you submit up, basically once you've trained it and got it all working, so you're not ready to run it on Kaggle yet, you'll have to basically run your model on this subset of the features, so some of the held out data, and submit your answer to Kaggle. I thought Kaggle could work a certain way with having 3 different labels, and I am wrong. So I will have to, I think I know how to make it work on Kaggle now, but it will mean that you'll have to, once you run your model on the 3 different labels, you're going to have to do like another script that kind of just concatenates them together at the right format. But if I can get that working, I'll just give you the script that does that. But that will be a bit later in the week, so hopefully Kaggle will be up maybe on Wednesday. But you can get started on it before that anyways, because you have enough data to train and test, and you've got labels in here. Okay, there's some questions in the chat here. I'm on Piazza right now, so which one? You're seeing that window, okay. all good questions. Okay, so first question there is there any, for the derivation type question, how do you upload it? I'm trying to remember. The simplest way is just to upload a PDF or anything you've scanned. The problem is I'm switching it to Mobius, which is very good for all these like multiple choice and calculation questions so that everybody can get a different number and stuff like that. But it's not great for handwritten things or derivations. So yeah, I'm not completely decided. Once I figure it out, I'll get it running this afternoon. I'll know for sure. But the for that question, you might be able to type it in LaTeX if you feel comfortable with that. But I would always give you an option actually to just handwrite it, because that's kind of more direct, and everyone should have the ability to do that. So you can take a picture of it or scan it and upload it. I'm just not exactly sure where the uploading will happen. So assuming on Mobius that works easily, there'll just be a button for you to upload the images. If that isn't great, I might actually just have a separate CrowdMark thing just for that question, because that would be very easy to grade. And so that would mean that for that one question, you'd upload your image there, but you just have to drag the whole thing up. Hopefully that wouldn't be too complicated. People are saying it's on 2 different systems. CrowdMark is much easier for that kind of marking of handwritten or multi-page documents, because then we can annotate on different sections of it. If that seems reasonable. Can we get extra material on Hufting and Mondrian trees? I don't really have anything extra. Like the stuff I talked about there is kind of all I've prepared on them. There's definitely papers on them, and I think I must have paper links for some of those in Zotero, but we could look for a few more. We have a paper we wrote on last year on Mondrian forests, and so in that paper, there would be references to all the related stuff of those other methods. And yeah, they're really good for big data analysis, because you're dealing with streaming data coming in all the time. I'm not sure if they're used a lot, like actually in industry and popular. So if you found links of them being used, talking about large-scale implementations of it, I'd be curious to see it. I know Hufting Trees is made by some profs at University of Washington, Washington State University. Yeah, Washington State. No, University of Washington. In Washington State in the U.S. And I know they're very proactive at commercializing and that kind of stuff. So maybe they have a consulting thing where they use Hufting Trees. I like Mondrian Trees a little bit better. I don't think they've been commercialized very much. Will the dates of test 2 and test 3 change? I don't think they can, because we're having the tests in the term, and the assignment is kind of due during the exam period at the end. So I know it's going to get a little more tighter now. Things are putting together, but I'll just make the tests a little bit smaller, like less stuff on them, but still cover the kind of the main topics. Yeah, because it's coming now, like every week you're going to have something, either an assignment or a test. But that last assignment's due like a whole week and a bit after the last test, so. Yeah, for what kind of stuff's on the test, if you go to OnLearn, this is another question up there. Tests, test 1, I've got a pretty full description here. So it's some subset of all this stuff. True, false, multiple choice, kind of matching of algorithms to data outputs, like was this, classification split created by a decision tree or naive Bayes, or a decision tree of how much depth. You should be able to kind of understand what created something. And then this derivation one, we've given examples of that. That's a more detailed thing. Niraj asking about the link for test one. Yes. So yeah, I guess the way it will work in terms of that logistically, I'll send out an announcement email. When I send an announcement on Learn, you guys all get an email notification. Sometimes this happens, sometimes it doesn't, because I can send an email as well. But I'll make sure that you get a direct notification with all the information. But there'll also be a link in here. So there'll be a new link in the test one category, and you will click on it and it will bring you to the site where you fill things in. And when you click on the link, you still have to say start. So it's not like you click on the link and your time has started. You click on the link and you'll go to the site that will show you the information, and then you'll have to say start the test. So once you click start, your time starts and you've got 3 hours to complete it. But you can do that anytime you want within the 3-day period. Yeah, great. Okay, papers and Zotero. Okay, yeah, so week 5, week 7, I just noticed there was that discussion. So I saw it last week, but I thought I had it all sorted out with what's next in terms of lectures. I was saying we're kind of like a little behind, and as I'm looking at also viewing of people's videos, that people weren't always viewing the ones from the most recent week. They were a few weeks back. So some of we're behind is because of my organization, and some of it's because you guys are probably focusing even more deeply on earlier topics, which is fine. I basically decided to drop on YouTube what is week 7, which is all the natural language stuff, which is not really a super detailed focus on the course, but it's an overview. So you can watch those as extra, but I won't use them as content. And so the next week of slide lectures, which I guess you could have been watching last week or you'll watch this week, is on clustering and support vector machines. And then after that, we'll have, on YouTube they're available, but I have to clean up these ones on Learn. After that, we go into deep learning, which I think is appropriate. But I updated them on YouTube, so YouTube's This Week channel now shows you what the next lectures are. Obviously, those aren't on the test tomorrow. Those are on test 2. That test info you're looking at. Really? No, we did that already. Test info. Why isn't it there? We had this discussion last week and I fixed it. Oh my god. Sorry. Okay. Didn't people tell me that? Did I miss a notice about this? Okay, apparently this description was not up there. I was sure it was. So this description was there already, but not the more detailed one. Sorry about that. Okay, well, now it's up there. So that would give you an idea on the types of questions. But the topics, hopefully, everybody could see them before. Right? The website had the topic list. So which weeks does it cover? Because since you didn't have that link there before. Week 5 had PCA feature selection. I think we said week 5 is not on the test, right? Yeah, because I said I wasn't changing what topics were just because it was delayed. Yeah, so it's week 1 to 4. So it doesn't include PCA and LDA and representation learning that we test 2. But, there can be questions on Huffington trees and modulated forests, but basically anything up to that. So decision trees, Emily map KNN. Yeah. All right. Sometimes these start date things only make them available at a certain time. Maybe that's what it is. Let's see if that helps. People were saying they still couldn't see it. Sorry, just trying to scroll back and see what questions I've missed. Question isn't up there. Week 4 to 5. Okay, it's visible now. Thank you. Great. Excellent. We can start the quiz now. No, you can't. How? It's one of these links. Well, what happens if you click on this link? This should not be the actual test. This is not the real test, so... Oh, quiz setup. Yeah, see, I had to... That's why I don't like Learn. It's so complicated. Right, so I hid the test because... Sorry about that. How do I... It doesn't make sense. Yeah, because I guess what I have is the... Alright, what I have, sorry, my brain's flying around now, is that text that I found for describing it is in one document, but it was connected to the actual test, which I used last year, Actually Learn. But now I will create a new note. Hopefully it's the same information. Alright, so you should be able to see that one. So now I will hide this one because that's just going to confuse people. I don't think that test would work if you clicked on it and tried to do it because it is not active. Your test is not going to be in that format. Alright, but this new one that I've created has the same information and it should be visible. Let's see if that works. You guys are great helping me debug everything. It shouldn't be the way it is, I agree. But these things happen sometimes. All right. Correct. Once you start, you have 3 hours to complete it. You can start anytime within, like, from tomorrow until Thursday. And then, yeah. If you have connectivity issues or something that causes you not to be able to finish in that time, then send a private message on Piazza. We'll be monitoring for those things, and we'll try to make sure things are fair, but it should be doable in much less than 3 hours, so we're trying to give enough time for that. Yeah, you get to see how stuff works behind the scenes. Why we complain so much about these tools. But as I find out, like, I try to look at some other tool to do tests. I was trying to export test questions from some other course for my other course I'm teaching to switch things, and it's like they don't even export to a common format that the other ones can import. So it's weird industry that everybody makes these different softwares for running courses, but every one of them is custom and different, and it's unfortunate that they can't all just be like simple, like questions are saved in a standard JSON format in some zip file that you can encrypt, and then it's just easy. That's how it should work. So somebody should develop that. Okay, so any non-website information kind of questions? Yeah, you're right. It should be in the description section. It's too late now. I don't want to change it again. Yeah, the Summit 1 grading has been delayed a bit. One of the TAs is trying to travel, and the other TA had some life events, so they're still working on it. It will be available by the end of this week, but it will be still a few more days for Assignment 1 grades. Okay, yeah, so I don't know how to say your first name, but Kakar has this question, reposting it. Good, I can get to it. Yeah, that would be great. So an overview of the different kind of representation learning methods and really summarizing it. I was actually thinking that after this year when I'm looking at all the YouTube videos of it, we should do that. But they're basically the ones we've talked about. We've kind of limited down to like the core methods that are used for completely different tasks. So there really is, for each of these methods we talked about, I guess a kind of a domain area of data or questions that it's more applicable to. Like, so ICA is kind of very specific to trying to, like the example we give is hearing different voices in a room, but it could be anything where I guess you're trying to extract a particular signal out of a noisy background, and you're looking for those patterns to hear particular types of signals in it and just get rid of the other ones. And so it's different than, you know, just trying to do Fourier transforms, because they're not pure signals, they're complex patterns, but there's some that are interesting and some that aren't, and you're trying to learn that. Whereas the other methods we talked about in representation learning wouldn't really help with that particular domain, whereas FDA helps where, or LDA, where you want to do classification and you want a smaller subset of kind of orthogonal dimensions, but it's going to be really good for classification. So they each have their own purpose, like realm. A question from Liming about, yeah, take pictures of, if you're doing a handwritten answer, like for the derivation things, definitely. No, I don't expect people to have a scanner. Most people don't have a scanner or a printer these days, right? Phone cameras, or any kind of camera, but obviously your phone probably is the easiest, are more than high enough resolution for that. So if you take a good picture, make sure it's kind of well lit and everything's readable and the paper is flat, so don't crumple it up after you're frustrated and then try to take a picture. You can take a look and make sure it's a pretty good, clear picture. Those photographs can be useful, and just organize them to upload into the system we give you. So if I give you a CrowdMark link, you can just drag those in, I think, as images, as long as they're, I think CrowdMark accepts PDF, PNG, and I don't know, GIFs or JPEGs. But if you got PNG images of it, you can just upload those and just write neatly, right? So if you're not typing it, you can handwrite it for sure, but just write neatly, make sure it's visible. Great. Assignment 2. Aha. Yeah, see? That has changed. So this statement of having that derivation in assignment 2, I just ended up dropping it. There is practice once on Learn though, so you can use that. And there are many examples online as well. Yeah, because I ended up adding more algorithmic things to the assignment rather than having that proof as well. So the assignment, you got a single data set, but you're going to do decision trees and naive Bayes on that data set, as well as trying to do PCA and FDA on it and see the difference. So there was more work than last time, so we removed the theory part. Ah, yeah, sorry, you asked about how many questions. I think it's 20-ish, but many of them are multiple choice and true-false, so each one of those counts as one. Yeah, in terms of number of questions. Good, okay. So that's a bunch of questions we had. Share what? Somebody suggested me share something. Oh, okay. The test, no. I'll try not to. All right, so somebody had a question on Piazza about KNN, which is kind of is related. It's one of the methods you can talk about, should be knowing about. I hadn't got around to answering this one yet. Talking about different ways to improve the calculation speed of some of these methods, right? So the k-nearest neighbors one, it's an interesting thing to think about, right? As well as like how well an algorithm, right? So now we're talking about algorithms that do classification or prediction or clustering, you know, or representation learning actually, like PCA, ICA. They're useful for certain domains, or like I was saying, like which, you know, data problem or task, I guess, which data analysis task is it useful for? So like I said, ICA, you're trying to pull signal out of the noise in a very particular way. K-nearest neighbors, you're trying to do classification on data points using some kind of distance metric. So knowing what they're for is useful. Knowing what they're isn't just about the test. It's just like, as a data scientist, machine learning person, developer, these are things that are useful to know, right? And what's it good for, right? It's good at certain types of problems. Some algorithms are better at certain types of data sets than others. KNN is very general, so it can apply to any kind of data points, because you're using, if the data is complicated, like they're images or something, then all you have to do is make sure that the distance metric that you're using corresponds to something that makes sense in that space, right? So if you had every data point not just be a bunch of numbers, but an image, then your distance metric, KNN, would only work if your distance metric was something that told you if two images are similar, right? So you could think about, how do you do that, right? You can have a distance metric that compares all the pixels and sees if they're, identical or similar, or you could do some kind of more complex distribution amongst kind of areas. But this question was about the other aspects of this, what their domains they could be used for, how you make them work, and how fast they are, right? So how slow or fast they are. So KNN's not particularly fast. It's a simple method, right? It's not like deep learning and it requires all this huge training. But for a simple method, it's actually not super fast, right? Because you've got to do comparisons between all pairs of points in order to get your prediction about what class a certain data point should apply to. So if you think back to any of your complexity analysis courses, right, anytime you've got to compare every element of a set to every other element of a set, you're going to have like this polynomial kind of explosion of computing time. And so KNN definitely has that. And so in that slide, I was talking about how you could make it faster. And I'm not an expert on this, but there's a bunch of methods that people talk about. You can just think about yourself what might be useful, right? That now that we've talked about representation learning and like a dimensionality reduction, right? So if you've got a 100-dimensional data set and you're trying to use KNN on it, it's going to be really slow because every data point has to be compared to every other data point, and that comparison takes 100 numbers to be computed because it's 100 dimensions, right? So if you just did dimensionality reduction and did PCA and use the top 3 eigenvectors and do KNN, then it might be actually quite a bit better, right? And it might still give you a very good answer because those top 3 eigenvectors would represent what? Right? The highest kind of independent directions of variance in that data. Other suggestions I had there was removing data points from the data set. You could just make it smaller. But the real way that people do it in more general is this third point, and I think that's what the question was kind of really about, is how can we do that? What's more detail? And if you look in the K-nearest neighbors library in scikit-learn, or if you read about it anywhere, they always have kind of these other approaches. So this algorithm tag in their library lets you pick different ways to do it. So the way we talk about it in theory is this kind of brute force approach where you're just computing the distance metric between points, right? But a more efficient way to do it is to use a KD tree or some kind of tree. Now this isn't like a decision tree, this is more like a binary search tree if you remember those. I don't know if they have a picture here. They don't. The idea is that you're trying to build a more efficient structure for telling if 2 points are near each other, right? And so if you have your cloud of data points and you're just saying, okay, these guys are near each other, these guys aren't, you could keep track of all the things you learn, right? So once you learn every neighborhood of data points had their distances, you build a tree that represents everything you know about that. And so you could think about how trees could basically give you a way to estimate the distance between 2 points, or calculate it exactly, but by using pre-saved values in a tree that kind of represents that whole structure. And so you don't have to ever recompute the distance between 2 points, because as long as you know the distance between a bunch of interconnecting points, you can kind of work it out. And so there's some very fast algorithms that do this and turn it from something like n squared to like n log n, which is still a big difference. So that's an algorithmic way to speed up that algorithm. Yeah, and in terms of, so Leming's got the comment there related to that at the end, that they did improve the time. That's good. And it would be more noticeable, I guess, the larger your data is, right? So the bigger n is, the more noticeable it'll be. Because if your number of data points is like millions, your KNN might be, you know, completely unworkable, and maybe with KD trees it would actually still run. Okay, 2 different questions. The ICA whitening, it would help to have the slides up. ICA updated slides, let's see. I mean, so the slides from ICA on whitening, I don't know if that gives it the most intuitive way. Oh, there we go. There we go. Yeah, the description of how we're computing the covariance matrix in the first place. Go see that link. My thought of how whitening works is that you essentially use ICA to compute this matrix, this new representation that lets you identify that signal, and then you center it, right? So you kind of subtract the you subtract this amount, this signal that you've got. And so then it becomes centered on that. And so you're essentially saying that you computed something where the signal you're looking for is pulled out, and then when you subtract that out of it, the kind of background noise get kind of canceled out and silenced or quieted down a lot. And so the point of it is that now it's all centered, and any kind of increases or decreases that you see from the main signal should be more related to the actual thing that you're trying to extract as a signal. So I guess the whitenings uses a pre-processing in this case, right? So by doing that, you're kind of finding all the Gaussian patterns of variance and then subtracting them so that they kind of get centered, and it makes it easier to detect what the true signal is going to be. But I have to go back and get into the notation he was using on this one to explain that better. Someone else's question on assignment 1 heart disease data set, whether they have cancer or not, could you have used logistic regression? What do people think? Does that seem reasonable? I think so. Because that's what logistic regression gives you, right? The ability to kind of take a bunch of inputs and produce a category output. You're limiting yourself to a linear model, right? That really represents the way that the variables interact. But then amongst that linear relationship, you're kind of using each of the parameters to feed into a probability model that will tell you whether it fits into that category or not. So that is one thing you could do, yeah. Can I find it? Oh, I see. Sorry, yeah. No, I was looking up something. Okay, so I don't know if that helps. I didn't clarify the whitening much more. I mean, if you look at that from that description, because the plot we had on the slide there is coming from this web page, so there's a bit more description on that web page. It's in the link of how they produce that plot for the whitening thing. And so you have your original data, and the whitening transform process has these kind of 2 steps. So you're producing that vector, just like when PCA or FTA were producing a bunch of vectors that kind of map data points from one space to another to change their kind of distances about their importance. But then they also have this whitening scaling transformation that helps it kind of become back into something similar in scale to the original one. So it might be rotated, but it kind of becomes at the same kind of scale and relationship as before, but now it's kind of rotated sideways. So it's kind of like, I think of it as a, when you're doing PCA, you produce all the eigenvectors and you've got these numbers and relationships between things, but then when you plot it down to 2 dimensions to see the relationship of the points, you're now, projecting every point here onto its, like for every point there, what's its 2 values in the first 2 eigenvectors, and you use that as your point for the plot, and now that point's there. And so now you've kind of projected it to something that you can actually interpret. There's a relation between theta and phi in the figure. Oh, I'd have to go remind myself what theta and phi are at all in these. I don't see any theta and phi in these. We've got rho. We've got, oh yeah, there's phi. Phi seems to be the rotation, so I think, okay, and theta is the parameter of the covariance matrices. So I think it's more like, yeah, that the first figure is mostly the thetas, I think, because it's the kind of relationship of the points to each other. And then maybe phi is that angle of rotation. And once you've worked that out, you can kind of re-project it. But I could be wrong. Okay. Other questions? We had a thing on Gini purity. No one has answered. Okay, so you're wondering why the entropy comes out at 0.5 as well instead of 1 for that one. But are you doing the log entropy? I wonder if the log is causing it to be, if you're missing a log, you might get 1 instead of 0.5 for this one. yeah, I'm not sure what's wrong there. This is the usual graph people show for it, so I'm pretty sure it would be right that it's at 0.5. I'm wondering for something where you have to basically, you should still go back to the exponent version first from the log version to get back to that number. But you're right about what you're getting at here is like the, because the cost here is at its maximum, and we're saying the cost is of getting it wrong, like when you basically have an equal chance of getting it wrong on either side. So your probability of getting it wrong is maximum at these very difficult points where the data points could be in one class or the other. If your model basically is a 50-50 chance that a point should be in one class versus the other, then your cost is going to be high because you're going to get it wrong a lot. And so that's what you want these different methods to say. Should I be using one that's harsh, like just using the true error rate, which would be very finicky if you got 49 versus 51 and then suddenly you're on the bad side, and your cost starts increasing, or you rather have something smooth like Gini or entropy. And you can see they're pretty similar at this pivot point, but they have different properties, I guess, further out when they're doing pretty well. The entropy is a bit more aggressive about penalizing you for getting things incorrect because the costs are still higher for the same kind of probability. They always listed as the two different methods people use for decision trees for evaluating them, and I haven't seen good arguments that like one is actually superior to the other. A lot of people are just more comfortable with entropy because it gets used a lot in machine learning, and it's got a direct analogy to a connection with probability, whereas I think Gini index is used more, especially in kind of maybe industrial or other areas where they like the concept of it because it connects to some things in economics. But I'm not sure what the explanation for your number difference is here. But I'll try to take a look offline and see. Okay. Great. Okay, we're still running. Okay, so other people have other things. I don't have other information to give. Like I said, there's a bunch for this assignment. I know you're going to be taking about the test for the next couple of days, but do try to take a look at the assignment or try to load up the data, make sure we haven't missed anything, but also you get the main idea of how to what we're asking. You're just going to be, again, using libraries from scikit-learn or wherever, because that's the most direct, on a bunch of different kind of tasks. But each of these tasks is basically the same data set, same task. You're just going to run another algorithm on it. So once you get your framework up, it shouldn't be a whole bunch more work. And we don't want to see, hundreds of pages of plots either. So it's more about, like I was saying with the previous assignment, helping you want to explore seeing a data set, figuring out how to get it working, and understanding problems and trying out different algorithms. And we've asked specific kind of results on some of the questions, but hopefully you can explore, the possibilities of these algorithms and see things that are interesting. When you find something interesting, you also want to highlight that. But yeah, don't try to give more things than are kind of really requested. And it's not like I said, I'll try to get the Kaggle thing up. That might hopefully be a fun thing to compete on. I'm not sure if it'll be what the accuracy levels will be like, so it'll be interesting to see that. So, if there's any other questions, we've been an hour there. We do have another bit of time, but if there aren't others, I might just sign off early, and you guys can get to work on things, and we can all get some stuff done. Any final questions? Okay, thanks everyone. Talk to you again soon.